Only five.
Anh không đi được phải tôi can tôi chỉ có là
In the last class, you have learned how to do the inverse Laplace for the basic one, and we apply the linearity property. Okay, linearity property. So today we will look at another property, okay, which is this first translation property. Okay, first translation property. This property is very important because normally you will use this when we are solving a differential equation by using Laplace transform. Okay. So this is the formula. Okay, this is the formula. So you have learned how to Laplace transform this to get fs minus a. So now we will look at how to do the inverse Laplace from fs minus a back into the function in t, in domain t. Okay, so if you look at the formula fs minus a, fs minus a, meaning that from your function, okay, from your function fs, okay, your s must be in the form of s minus a. Okay, all s must be in the same form, which is s minus a, before you can start to apply the first translation formula. Okay, so all s must be in the same form, which is s minus a. So if you look at this question, okay, normally we start from the bottom. If you look at the bottom function, s minus 4 to the power of 4. S minus 4 to the power of 4. So this is s minus 4, meaning that if you have s at the top, okay, if you have s function at the top, that s must be also in the same form with this s minus 4. Okay, there's an s at the top, and this is also in the form of s minus 4. So this is a ready form. Okay, this is a ready form where we can apply the first translation property because all s are in the same form of s minus 8. Okay, all s are in the same form s minus 4. Okay, now we will start to inverse Laplace to get this. Okay, so we will take out the a. Okay, we take out the a to form the EAT. Okay, we take out the a to form the EAT. So here we will take out the 4. Okay, take out the 4. So you have E4T. Okay, E4T. So once you have taken out the 4, that means here you have only s. This one only s. Okay, once you have taken out the 4, you have 2s plus 1. And at the bottom, you have s power of 4. Okay, so you get this one, 2s plus 1 over s to the power of 4. Okay, here you break this into 2 so that you can inverse Laplace these two functions separately. Okay, so 2s over s to the power of 4, you cancel out 1s, you get this. And this one, okay, this is the second term. So these are the basic of the inverse Laplace. Okay, from here, here, and from here to here, this is what you have done in the last class. Okay, the inverse Laplace. Okay, I repeat. To apply this first translation property, okay, if you look at the formula, okay, s minus a, meaning that in your function, in the question, okay, the function, all s must be in the same form, which is s minus 8. So we will always start from the bottom. Okay, the bottom is s minus 4. Okay, s minus 4. So at the top, if you have an s, that s must also be in the form of s minus 4. Okay, so this is in the ready form that we want. Okay, so we can start to take out the a. Okay, if you take out the a, then you have EAT, inverse Laplace Fs. Inverse Laplace Fs is the Ft. This is how we do the inverse Laplace using the first translation property. Okay, take out the a. So now when you take out the a, when you take out the 4, you have E4t. Okay, E4t. So here you have only 2s plus 1 over s to the power 4. Okay, then here you just break this into 2 and solve the inverse Laplace as what you have learned in the last week. Okay. Okay, so if we look at this question, okay, question number 1 exercise, at the bottom we have s minus 1. Okay, s minus 1. So meaning that if you have an s at the top, make sure this s must also in the same form of s minus 1. So if you do not have s minus 1, means that you create the s minus 1 for the top function. S minus 1 plus 1. Okay, we create the s minus 1 for this function. Okay, if you look at this second function, okay, this one, okay, after you factorize the 2 from the bottom, you have s minus 3. Okay, you have s minus 3. Okay, but this one, it has no s. Okay, so we don't have to change anything. This one, you can Laplace, inverse Laplace directly. But if you look at question number 3, this one, in your list of formula, you do not have a formula for s plus a or s minus a squared plus a squared. You do not have such function. So we have to apply the first translation to get rid of this plus 3. Okay, to get rid of this plus 3. So we have to apply the first translation. Okay, the first translation to get rid of this plus 3 so that you have s squared plus 9. Okay, s squared plus 9 only at the bottom. So before you apply the formula, this is at s plus 3. So we want s plus 3 at the top as well. Okay, so we create the s plus 3. Okay, so we try this one. Okay, we try this. The idea is all s must be in the same form before you apply. And why we want to apply this? Because in the list of your formula, we do not have the s plus or minus a squared, then plus another value. We do not have such a formula. But after you take out the plus 3, this one, after you take out the plus 3, you have s squared plus 9. Yes, we can find the suitable formula for you to do the inverse Laplace, either cos or sine. It depends on the function at the top. Okay, this is why we need this first translation. Now let's try this. inverse Laplace of this function. So f minus 1 to the power of 4. If you look at your list of formula, you do not have such a formula. Okay. So if you look at this one, and you compare this to your list of formula, you do not have such a formula that suits this. Okay, this is a S followed by a constant and then power of 4. Okay, so power of 4 meaning that if you look at the list of formula, this is the one, the t to the power of n. Okay, the one t to the power of n, it gives you the suitable formula, but this is n factorial over s n plus 1. Sn plus 1, then only you can get this 4. For the rest of the function, they are not suitable, right? Power of 4. This is the most suitable one. But according to this, you have only s. You do not have s plus a or s minus a. So we want to get rid the minus 1. Then only you can proceed to use this. You get what I mean?
Yes.
Okay, so how to get this? Okay, you have to apply the first translation property, where you have to make sure all s from this function, all s, they must be in the same form of s minus 1. So we have an s here. Okay, we have an s here. So we want to come up with that s minus 1 plus 1. Okay, we want to have this s minus 1. So we change the s into s minus 1 plus 1. We do not change the question. So that you have 3s minus 1 plus 3. Okay, plus 3. Because this is your A, this is your B. 3A plus 3B. Then you get this 3A plus 3B. Okay, then s minus 1 to the power of 4. Okay, now this is in the ready form that we want. We can start to take out the 1. Okay, we can start to take out the 1. Okay, according to the formula, you have to always refer back to the formula. The formula is, I write it here, inverse Laplace fs minus a equals to e a t. Okay, because this one, once you take out the a, you have e a t. And then what is left? You left fs only, right? After you take out the a, you have fs. So inverse Laplace of fs is actually ft. So this is the formula. Inverse Laplace of this function equals to EAT ft. Okay. So refer to this. When you take out the a from the s minus a, okay, from the s minus a, this is your a. So when you take out your a, you have EAT. This is similar to the unit step function, right? You take out the minus a, you form the e minus as. That is Laplace transform. Okay, that is Laplace transform of the unit step function. When you take out the minus a, you form the e as. Okay, sorry, e negative as, the one unit step function. But here, this is inverse Laplace. This is Laplace transform, you get s. This is inverse Laplace, you inverse s, you get t. Okay. And this one, the formula, it follows the h t minus a, right? You take out the minus a, you form the e minus as. But for this one, this is different. You see the difference? This is minus, this is plus. So if this is s minus 1, this is E1t. If this is s plus 1, this is E negative t. This is Laplace this is inverse. Inverse, that's why we get the function back in t. For the Heaviside function that day, you are doing the Laplace transform. Okay, you are doing the Laplace transform. You take out the minus a because the Heaviside function, this is always minus. When you take out the minus a, you get E minus AX. So I hope you do not get confused by these two different things. This is first translation of inverse. This is Laplace transform, not inverse. This is Laplace transform of unit step function. Okay, so back to this question. S minus 1. So that means your A is 1. Okay, your A is 1. So when we take out the A, we have 1t. 1t. So what is left in the bracket? Okay, no more minus 1. Okay, once you have taken out the 1, you have only 3s plus 3. This one is s power of 4. So this one, how to solve this? You break this into 2, right? 3s over s to the power 4. And then another one is 3 over s to the power 4. This one, you can cancel out 1s. Okay. For the first term, you can cancel out the 1s. Okay. So this one, when you cancel out 1s, you are inverse Laplace 3 over s cubed. And for the second term, s to the power 4. What is your n? N is 3. When n is 3, you need a 3 factorial. Okay, 3 factorial is 6. You need a 6 instead of 3. So you can take out the 3, insert the 6 as power of 4. Or just write a 3 factorial. So can 3 factorial. Continue here. So ET. Okay, inverse Laplace of this. This is n is 2. Okay, n is 2. So we need a 2 factorial at the top. Take out the 3. Insert the 2 factorial. So here divides the 2 factorial outside. And this is 6. 3 over 6 is 1 over 2. 1 over 2. This is t to the power t to the power 3. Okay, because your n is 3. So this is 3. So 3 over 2. This is t squared. Any questions? You have to understand why we have to apply the first translation. Did you know why we need this first translation? Because from the question, we have s minus 1 to the power of 4. We have something like this, s minus 1 to the power of 4. Okay, we can't get to match any of the formula. So, but after you take out the minus 1, you have s power of 4, then you can apply, and we can take the 1t to the power of n. Okay, t to the power of n. That's why we need first translation to get out, okay, to take out the minus a or plus a from the s. Okay. Look at the question number 2. Okay, number 2. So first, we have to factorize the 2 from the bottom. Okay, factorize the 2 from the bottom. When you factorize the 2 from the bottom, have 1 over 2 s minus 3. Okay, this one, actually you can directly apply the formula using the EAT. But actually, this one, we can also solve using the first translation because we can take out the minus 3. Okay, we can take out the minus 3. Let's say now we are using the first translation. So match this one. Your A is 3. Okay, your A is 3. There's no S at the top, so no issue. A is 3. So when we take out, we have 3t, E3t. So what is left inside the bracket is 3 over x. 3 over x. 3, we can factorize the 3. And inverse Laplace of 1 over s is 1. Okay, or you use the formula of the 1 over s minus a. Okay, you can apply this one directly. Okay, this one I apply the first translation. Three over 2. Last one, try to get it. This one, factorize inverse Laplace 1 over x is 1. Okay, inverse Laplace number 3. We will always start from the bottom function, the denominator. We have s plus 3 squared plus 9. Okay, we do not have such a formula to be applied directly. But after we take out the plus 3, okay, after we take out plus 3, you have s squared plus 9. Okay, so we want to take out the plus 3. Okay, initially, our intention is we want to take out the plus 3 before we do the Laplace transform. But before you take out the plus 3, okay, means that you want to apply the first translation property. If you want to apply the first translation property, you have to make sure all s from this function, there must be in the form of s plus 3. So we have an s here. Okay, so we have to do something to this s. We want to come up with an s plus 3. So we leave, okay, you leave some space for the s. We want the s plus 3. So s plus 3 minus 3. Because we want this. Okay, then open the bracket, simplify. You preserve the s plus 3 at the top. So we open the bracket, then we simplify s plus 3. Preserve the s plus 3, and then minus 3 plus 1. Minus 2. Okay, so now this is what we want. Okay, this is what we want. Then you can start to take out the constant. So compare this to the formula. Okay, the formula is s minus a. S minus a. So your a will be
minus 3.
minus 3 because your formula is s minus a. S minus a. So your a is negative 3. So e negative 3t. Once you've taken out the 3, you have only s minus 2. And s squared plus 9. So to solve this, break this into 2. One with s, one without s at the top. Then you will get the answer. S over s squared plus 9. Another one is minus inverse Laplace of 2 over s squared plus 9. Okay, break it into 2. This first translation property is always popular in finance exam. Always. So when you break this into 2, the first one, what's the first? Inverse Laplace of this, you get Cos. Cos 3t. Okay, cos 3t. And the second term, this is sine. This is sine. Okay, we need an 8. 8 is 3. We need an A here. We need a 3 here. We don't want 2. Take out 2. Okay, take out 2. Insert the 3. Once you insert the 3, divide the 3 outside. So you get a 2 over 3 sine 3t. Okay, any questions? Next, we look at question number 4. Okay, question number 4. The denominator function is a quadratic function. Okay, it's a quadratic function. And we can't get to match this one with any of the formulas. So what we do, we complete the square. Have you heard about completing the square? For example, s squared plus 2s plus 1. Okay, let's say this quadratic function, we want to do the completing the square. We want to complete the square. So s squared, okay, you just write an s, okay, s, and then this is a plus 2, okay, plus 2s. We just take the plus 2. We take the coefficient of the s. Okay, the coefficient of the s is plus 2. So this coefficient we divide by 2. So plus 2 divided by 2 plus 1. Wait. Okay, then you have to minus the square of this value. Okay, the square of this value. Okay, the square of plus 1 is 1. Okay, 1 square is 1. Then plus this 1 back. Okay, meaning that this term comes from this. These two terms we write in this form, and then plus 1. Okay, because when you try to expand this one, this part, you just look at this one. When you expand s squared plus 2 times 1 times s, you have 2s, and then plus 1, then minus 1. So you see, this is actually same as this. Okay, completing the square. So if we look at the formula, s squared plus let's say I use b. Okay, supposed to be ABC. Okay, supposed to be ABC. AS squared plus BS plus C. But if your s squared, okay, if your s squared, the coefficient is not 1, okay, then you have to do the factorization first. You factorize the a first. So you have s squared plus b over as plus c over a, correct? When we factorize the a, we get this one, right? Okay, then we start to complete the square for this term. Okay, when we do the completing the square to these two terms, the one with s squared and s, so we have s, okay, s squared, we just write as s, okay, plus this value, okay, this value divided by 2. This value divided by 2. So if this is plus, this will be plus. If this is minus, this will be minus. Okay, plus this one divided by 2 is b over 2a, right? This value divided by 2 is b over 2a. And then close the bracket square. Then minus the square of this b over 2a squared. Okay, minus the square of this value. Then only plus the c over a back. This is the formula. Okay, if you want a formula, this is the formula. Okay. Okay, I give another example. Let's say we have s squared plus 3s minus 5. Let's say the coefficient function is 1. Okay, so we don't have to do the factorization. So we will start directly. S squared, we write it as this value plus 3. Plus 3 divided by 2. 3 over 2 plus 3 over 2. Close the bracket square. Then minus
3 over 2.
Minus the square of this one. The square of this is 9 over 4, right? Minus this one. Then continue with this. Minus 5. Then you simplify s plus 3 over 2 square. This one minus this. So 29 over 4. Okay. So when your bottom function is written in something like this, then only we apply the first translation to take out this value. Okay, I give another example, the one with coefficient function other than 1. Okay, other than 1. What's happened if you have a value other than 1? Let's say 2s squared plus 3s plus 1. Okay, let's say this one. Okay, this is not 1, so we have to factorize the 2 first. Factorize the 2 first. So what do you have here? S squared plus 3 over 2 s plus 1 over 2, because we factorize this value first. Okay, then only we complete the square for these two terms. Okay, now 2, okay, give a big bracket. Okay, s squared, open the bracket, s plus 3 over 2 divided by 2. This one divided by 2, plus here will be plus. 3 over 2 divided by 2, 3 over 4. Close the bracket square. Minus. What is the value that you need to minus?
9 over 16.
9 over 16. And then plus 1 over 2. Okay. Then you will get this. Okay, this two. Then you get this. Okay, this is what we want. We want something like this. And then followed by a constant. Okay, now we're back to this one. Okay, we're back to this question. We want to complete the square for this part. Complete the square. So I do the completing the square. Let's say here. 4s squared plus 4s plus 1. Okay, so we factorize the 4. We factorize the 4. So you have s squared plus 4 over 4. That means 1s plus 1 over 4 because you are factorizing the 4. Factorizing the 4 from all of these terms because we want s squared times 1. We want s squared times 1. Okay, now after that, okay, give a big bracket, then we will start to complete the square for the first two terms. 1. Okay, so open the bracket, s squared, we just write as s. Okay, plus, we follow, plus. What is the value here? 1. 1 divided by 2. 1 over 2. Close the bracket, square. Minus. 1 over 4. 1 square get 1. 2 square get 4. Then plus 1 over 4. Okay, simplify. This one, 0. Okay, so we have only this. Okay, back to this question. Okay, we rewrite so that you can see clearer. 3s minus 5. Here will be 4s plus half squared.
Oh, this is new question. This is our new question.
Yes. So this one, if you compare to the given formula, which one? Which one you have to use?
Close.
Yeah.
Close.
If you use cos, you do not have a plus a squared. This one, no matter how, you have to take out the plus half. You have to take out the plus half. We don't use cos or sine because cos or sine, you have a squared. We do not have a squared here after the s squared. Okay, so we use the 1 minus this one. Not this one, this one. We have the square. Okay, we have the square. Okay, so your s is in the form of s plus half. So this s okay, so this s we want to create the s plus half and then minus half. Okay, then we can take out the what is your a? Compared to this, what is your a?
Minus half.
Minus half, right? Minus half. So you have e minus half t. Okay, follow this one, t. So what is left in the bracket? You have 3s, this one non, minus half, minus 5. 4s squared. Okay, so this one you have to simplify first. So 3s, okay, negative 3 over 2 minus 5. Okay, negative 3 over 2 minus 5. So how to proceed? We have to break it into two, right? We have to break it into two. So 3s over 4s squared. Another one is minus 13 over 2 over 4s squared. Okay, simplify. Simplify. Cancel out 1x. You have 3 over 4x. 3 over 4x. And this one, factorize the 13 over 2 and factorize the 1 over 4. You have 13 over 8. Okay, this one, take out. 1 over 4, take out. Start to do the inverse Laplace for these two terms. Okay, continue here. Okay, the last. So you have e half negative half t. What is this? This one? Over 4. Okay, 3 over 4. Because when you factorize 3 over 4, you are inverse Laplace 1 over s, which is 1. Minus 13 over 8. This one is t, right? Inverse Laplace 1 over s squared is t. Okay, any questions? Now we look at question number 5. Settle the completing the square. Completing the square. 2s squared minus 8s plus 16. You have to factorize 2. You factorize 2. So once you factorize 2, you have s squared minus 4s plus 8. Okay, then we start to complete the square for these two terms. Right. Square, we have an s
Minus 2 squared.
minus 2 square minus
Minus 4.
4, the square of 2. Okay, this one it will always be minus, minus the square of this. Okay, minus the square of this. So negative 2 times negative 2, you get a 4. Okay, this is always a minus. So minus 4 and then
Plus 8.
plus 8. Okay, simplify as minus 2 square plus 4. Okay, now you put this back. Okay, we write the bottom function first. 2 s minus 2 plus 4. So from the bottom function, we know that the s is s minus 2. And we have an s at the top. So we want to come up with the s minus 2 for the s at the top. So 2s minus 3. Okay, we form the s minus 2 at the top. S minus 2 plus 2. Okay, you can either simplify first or you can either take out the a first. If you want to simplify first, that's fine. This is 2s minus 2. Okay, s minus 2 and then plus 4 minus 3. Okay, and this one we can take out the 1 over 2. Take out the 1 over 2. Okay.
Okay.
We take out this 2, factorize this 2 from the bottom, so we have 1 over 2. Okay, 1 over 2. So this is your bottom function, and your function at the top, we do some we preserve the s minus 2. Okay, and then 2 times 2, you get a plus 4, and then minus 3. Now we take out the 2. Okay, s minus a, s minus a. So your a is 2. A is 2, so 2t. So what is your function at the top?
S
2 s plus 1. And this one will be s squared plus 4. Okay, because we have taken out the minus 8. Okay, no more a, take out the a, take out the a, so you have only s. So 2s plus 1. Okay, then separate this into 2. Separate this one into 2. Give a big bracket. Okay, separate. So what is the answer for the first term? This is the cos. So the answer is 2 cos 2t. Okay, this is your a squared. Okay, this is your a squared. So 2 cos 2t plus. Okay, this one we need a 2 at the top. Okay, we need a 2 at the top. So you insert a 2 outside, divides by 2. This is a sine 2t. Okay, any questions for number 5? Any questions? Okay, if no, okay, one more. Question number 6. Okay, try to complete the square.
What's that?
Plus 2. Plus 2 square. Minus the square of 2, which is 4, minus 5. minus 9. Okay. Do you get this?
Yeah.
Okay. S plus 2 squared minus 9. Then we look at the function at the top. There is an S here. Okay. There is an S here. So 8 S plus 2 minus 2 plus 13. Okay, so if you want to simplify first, okay, you can simplify. You have 8s plus 2 minus 16 plus 13. Okay, this means minus 3.
So our A is minus 7.
Okay, so we take out the 8. 8 is minus 2. 8 is minus 2. So E minus 2 T. So what is left in the bracket? 8 S minus 3 over S square minus 9. Then break it into 2. Okay. Break it into 2.
Sixteen of this. 16 también porque lo sale en Oh, esto es la
Rating non less of your 8. Hyphen cos 3t minus. This is hyphen sine 3t. This is minus, so this is hyphen.
Why you choose high but beside and minus something?
This is minus.
Yes, the money code minus
Okay. We look at partial fraction. Okay, actually these partial fractions, if you look at the syllabus from the teaching plan, you didn't see this part partial fraction. Okay, but why this is still introduced in the class? Because when you solve a Laplace transform, when you solve a differential equation using Laplace transform, the last part where you need to do the inverse Laplace, sometimes when it involves the question something like this, actually partial fraction will be easier. Okay, so in short, the question, okay, we look at a question something like this. If the quadratic function from the bottom part can be factorized, actually you can also use partial fraction to solve the inverse Laplace. Okay, but if it is not factorizable, we have to use the completing the square. Okay, so no matter it is factorizable or non-factorizable, actually we can use the completing the square. Okay, completing the square can be used, okay, for the function, for the quadratic function, whether it is factorizable or non-factorizable. Okay, but if it is factorizable, actually maybe partial fraction will be there. Okay, it depends on you. You can choose any method, any method. So I just introduce to you. Okay, because this partial fraction is what you have learned before you are here. Okay, partial fraction. Okay, so there are a few forms of the rational function. Okay, so if we normally look at this, the bottom part first. Okay, if you have this x minus a, x minus b, we can break this into two. Okay, x minus a, another one is x minus b. Okay, but since this is x power of 1, so at the top we just have the constant. Okay, constant. When you have x power of 1, we just take the constant. Okay, another one, x minus a squared. This is a repeated root. Okay, repeated root. So we have x minus a power of 1 followed by x minus a power of 2. Okay, if this is a cube, okay, power of 3, this means x minus a squared, x minus a cubed. Okay, repeated root. Okay, and since this is x power of 1, so this is a. This is also x power of 1, so this is b, constant only. Okay, another one, okay, this one is simple. Okay, we can have this, we can break it into 3, and all of these are constants because x power of 1, 1, 1. Okay, if you have this case, okay, this one, this is for repeating, okay, repeating. Okay, repeated root, so power of 1, another one is power of 2. And then x minus b. Okay. So here, this is still a constant only, x power of 1. This is also x power of 1 constant. X power of 1 constant. But if you have this one, this is no longer x power of 1. This is x squared. Okay, this is x squared. That's why at the top you have bx plus c. Okay, bx plus c. This will always be 1. The degree will always be 1 less than the bottom one. Okay, 1 less, 1 unit less. Okay, so x squared, when you have x squared, this will be a constant x plus another constant. This is still power of 1, so this is still a constant. Okay, so now we look at this one. Actually, there are two methods, okay, two different methods for this partial fraction. Okay, we just go through. Okay, we just go through. Okay, this one we can break it into these two. Okay, break it into these two. Then 1, okay, 1 is equals to a times s minus 2. This one, how to get this? We combine these two into 1. Okay, we combine these two into 1. Meaning that how to combine s plus 1 times s minus 2. Okay, this one you have to times multiply s minus 2 top at the top and at the bottom. For this term, you have to multiply s plus 1 at the top and at the bottom, so that the function of denominator is the same. Then we can combine the top function. So in short, we have a times s minus 2 plus b times s plus 1. And on the left hand side, we have 1. Okay, I'm not sure how you learn about this partial fraction, okay, but you just use the way that you have learned to break this into the partial fraction. Okay, then we can simply choose any value. Okay, simply choose any values, the suitable one. Okay, s minus 2, we choose s as 2. Because 2 minus 2, we get 0. So 1 unknown is gone. 1 unknown is gone. We have only 1 unknown left. Okay, when s is 2, 2 minus 2, 0. 2 plus 1, you get 3, 3b. So 1 equals to 3b. Then you will get b. Okay, another one, we can choose s equals to -1. Okay, when your s is -1, this term is gone. S is -1, you get -3a. 1 is -3a, then you can get the value of a. Okay, after that, you just substitute the values that you obtain back into here. Okay, that means you have this. Okay, we have break this into this. Okay, then you just proceed to inverse Laplace. Okay. Okay, another method. Okay, when you have more. Okay, when you have more unknowns, you have ABC now. Okay, and here you have square. Okay, this is another way. Okay, this is also a partial fraction. Okay, so this one we can break it into these two. Since this is square, we have bs plus c at the top. So we combine these two. Okay, so s equals to a times this plus bs plus c times s plus 1. Okay, when you get this, okay, we categorize. Okay, we categorize the term for s squared. Okay, so that means here you have to expand. Okay, expand bs squared plus bs plus cs plus c. This is a s squared plus a. Then you categorize the one with s squared, the one with s, the one without s. Okay, categorize. Then we compare the coefficients from the both sides. Okay, so first we compare for the s to the power of 0. S to the power of 0 means no s. Okay, no s on the left is 0, and the one on the right, no s, is a plus c. Okay, and for the second term, okay, s power of 1. Okay, s power of 1, you have 1. Okay, and on the right, you have b plus c. Okay, you have b plus c. And for the term of s squared, okay, on the left you have 0, and on the right you have a plus b. Okay, then you solve these three equations simultaneously to get the ABC. Okay, then put the ABC back into this one. Okay, then from here continue to do the inverse Laplace. Okay. So if you know how to do the partial fraction, then maybe you have another method. Okay, you have another choice to solve for the inverse Laplace. Okay, this one. Okay, this one I leave it to you. This one, because this is not in the syllabus. This is just for you to have one more option to solve inverse Laplace. Okay, one more option, because actually you can solve using the completing the square by using the first translation. Okay, you can use the first translation, but when the the degree of the equation at the bottom is more than 2. Okay. When it's more than 2, for example, this one, this is when you expand, you get s cubed. This one, you get s cubed. And this one, you get s cubed as well. For completing the square, that is only for quadratic. So what's happened if you have more than 2? Okay, you will learn another method called convolution theorem. Okay, actually the first translation and convolution theorem are enough to cover for all kinds of questions. Partial fraction is just a choice and alternative choice for you to solve when the denominator function is factorizable. Okay, just another option. So this one, I leave it to you to have a try. Okay, and for the convolution theorem, okay, because of the aircon issue, I think all of you want to rush out to the classroom with it. Want to rush up from this classroom. So I think. Okay, so I will continue the convolution theorem in the next class. Okay, the convolution theorem. Okay, so today we stop here. Okay, you can try this one. You can try on your own using the knowledge of partial fraction that we have learned before next one. Okay.